Welcome everyone to my talk, Solving Imaginary Scaling Issues, which is, I gotta say, a personal journey amongst wrong architectural decisions that I personally made in my past. So I want to share with you something that I made wrong in my past, and maybe we can all learn something from my own mistakes. So yeah, let's get started with that. So I'm Michele Riva. I'm a Google developer expert in a Google Cloud platform. I am a senior software architect, and I'm also a book author. So that's what I like to do, and I'm super glad to be part of the Google developer expert community, and because it allows me to join beautiful communities such as yours and meet many different people from all over the world, which is still incredible to me. It's really enjoyable as a thing. Everything we will discuss today has started from this very image that has been shared on Twitter by the Practical Dev, which is the account behind dev.to and other great social networking websites. And it started as a joke, but eventually it got me thinking, yeah, we are really trying to solve imaginary scaling issues when we try to design our architectures. So that made me think, of course, and that's where I want to start today. So before we get into the imaginary scaling issues, I want to talk about scalability. So what is scalability? Fullscale.io says that scalability is an attribute of a tool or a system to increase its capacity and functionalities based on its users' demand. Scalable software can remain stable while adapting to changes, upgrades, overhauls, and resource reduction. So that's really important. And we want to focus on 4 different concepts. Scalable software can remain stable while adopting changes, number 1, upgrades, number 2, overhauls, number 3, and resource reduction, number 4. So changes, talking about changes, we are referring to the system should remain stable when applying any kind of change to both the infrastructure and the application. For example, switching from computer engine to Cloud Run to make the whole infrastructure more cost effective. That's a typical example. So if we will to go into that migration, the whole system should continue working. That's really important. Upgrades. The system should remain stable when upgrading any of their components. For example, releasing new software version or upgrading the runtime. So if I'm working on Node.js 14 and I want to upgrade the runtime to Node.js 16, then my system should stay online and available for everyone. Overhauls. The system should remain stable during maintenance and debugging. For example, if the system is not working properly, it should be easy to inspect production deployments. So that's debugging and try to understand what's going wrong. That's really important. Resource reduction. The system should remain stable under high load. For example, an e-commerce is rolling out a great promotion with huge discounts. There's a lot of traffic on the website and the connection should remain stable. So by resource reduction, we mean we have like a server with, let's say, 1 GB of RAM, but we have to share this RAM for every single connection. So as our connections grow, we want to be able to serve every single connection by maintaining just 1 GB of RAM. So that's an example, that's a possibility. And we want our systems to be capable of doing that. So we just seen 4 different scenarios. And I feel like all the imaginary issues that we think of will start from as an overreaction to those 4 scenarios, I would say. So starting from there, I want to point out 4 different issues. I could stay here talking like forever about the bad decisions I made, but I had to have like 30 minutes, so I will do just 4 of them. So imaginary issue number 1, this programming language doesn't scale. That's the number one, and it's also one of my favorite ones, of course. So when we say PHP doesn't scale, what do we want to point out? I mean, Facebook, it's written in PHP and it's scaling pretty well. And of course, I know they're compiling they're compiling PHP down to C++ and running everything on the HHVM virtual machine. So they're doing some great optimizations. But again, they are Facebook. They are running a huge load of traffic. But if we think of like websites such as Wikipedia or great websites supported by WordPress, then we are talking of very big websites that are built and implemented in PHP, and they are scaling well. So we also have the example of Ruby on Rails, when back in 2008 they were willing to abandon Ruby on Rails in favor of Java and Scala in general, because Ruby on Rails couldn't scale anymore. So we are full of bad examples of languages that couldn't scale, but we would get into that later. And we have also great example of languages that are built to scale, such as Erlang, for example. So we have WhatsApp, which could possibly scale forever. We will see some numbers later on. And so my idea is, do we really need to choose a specific programming language to make our system scalable? So let's debunk the first issue. You are not likely to rewrite Facebook, Twitter, or WhatsApp. So that's the biggest problem we have today. We start thinking of our systems like they were incredibly scalable systems such as Facebook, Twitter, WhatsApp, or your favorite big social network. But we are unlikely to go build something like that in the future. And if we do, we need a very big team supporting us. So let's see what I mean by you're not Facebook. We are not Facebook. In 2021, Facebook were serving 2.9 billion monthly active users. And it's a lot. I mean, we are almost 8 billion people in the whole planet. That means a lot of them have access to Facebook. So that's the grade of scaling that Facebook is going to provide to us. And we are unlikely to build something as big as Facebook. Okay, so we were saying Facebook is serving 2.9 billion users, and we are unlikely to, serve such a high traffic, high load in the future. And WhatsApp is serving 100 billion messages every single day. And of course, they're doing that. And so we could potentially build something like that, but we are unlikely. So that's my point on the first myth. So how many active users do we have today? That's the first question we should ask ourselves when building something. How many active users do you expect to have in 5 years from now? How much would it cost to teach your whole team to code in Erlang, Rust, C++, Scala, or any other highly scalable language? So we saw a moment ago how Twitter has to run away from Ruby on Rails because it couldn't scale anymore. But today we see Shopify, and this is a tweet from the starting of December, where Shopify on Ruby on Rails and MySQL were serving 30 terabytes per minute of data, which is a lot. And they're doing that thanks to Google Cloud. So, I mean, big applause to Google Cloud for doing that. But also that shows us that there is not a perfect programming language for scaling. And that brings me to the last point for, that imaginary issue. Good PHP code scales better than bad Erlang code. And good Ruby code scales better than bad Scala code. And I mean, Shopify is kind of proving that, right? We saw how they can really scale with Ruby on Rails and MySQL. So imaginary issue number 2. We need to use cloud functions to manage high traffic. Serverless computing scales better. But at what cost? So that's my question here. And I want to play with some numbers now. So these are some numbers I found on the Google Cloud Functions pricing tier. So we have first 2 millions of invocations per month that are free, and then we pay only 40 cents per million for every single million for every million of invocations. We also pay for compute time. So 128 megabytes of RAM costs such a low number that I can even pronounce that in English. So it's really, really cheap. And then we have to pay for networking. So we have the first 5 gigabytes for free, and then we pay only 12 cents per gigabyte, which sounds cheap, right? Let's make some math. Let's try with a very simple REST API example. So let's say we have a simple but critical REST API that gets 50 requests per second, which translates to 129,600,000 requests per month. The average execution time for that API, it's about 300 milliseconds. And we can use the cheapest RAM option, which is 182 megabytes on Google Cloud Functions. That would require around 1 kilobyte of bandwidth per execution. So these aren't big numbers, right? So let's make some math. That would cost around $1,620 per one single month. And what if we are lucky and our user base grows and we get from 50 requests per second to a constant 100 requests per second, meaning 259,200,000 requests per month. So we are doubling the requests per month we get. We go up to 3,245 requests, dollars every single month. So my point is, are you sure that serverless computing is really cheaper? Let's try with something else, something else that Google Cloud Platform can provide us. We have Cloud Run. So with the exact same amount of requests and memory allocated, and it's just the same setup, but we will pay $192 per month, which results in more than $3,000 of savings every single month. And what if we go on Compute Engine? I mean, we could use one of the cheapest machines we find, and we end up paying only $52 per month. And we would be able to serve the exact amount of requests thanks to the configuration of the machine we are looking at. So issue number 2 is debunked. Cloud Functions are good at managing spiky and unpredictable traffic. If we have spiky and unpredictable traffic, then Cloud Functions are awesome, because we don't have to manage the scalability of our servers. Everything, we're getting a lot of help from the Google Cloud team, basically. So they will help us. But when the traffic is stable and it's constant, we just don't need it. So that's a great lesson I learned, the hard way, because I started to pay a lot. And then I said, okay, maybe it's not the best solution for what I'm doing. And I found this tweet where there is a person, really smart, which makes like $5,000 per month on a $7 dyno on Heroku. So again, this is what I think is really, really smart. Achieving great results with a minimum waste of resources. So we are heading to imaginary issue number 3. NoSQL database scales better than relational database management services. And I cannot stop sharing enough this tweet again. We already saw that, but it's brilliant. Again, they're serving 30 terabytes per minute, which means 43 petabytes of traffic per day. And I'm telling you, petabyte, which is a lot. I can't even imagine how much a petabyte is because it's really huge. And they're doing that using MySQL. So again, Of course, NoSQL scales better. It depends. If you're good at writing SQL queries, then Postgres or SQL could scale better, and that's the case for Facebook, Uber, Netflix, Instagram, Spotify, Twitch, Reddit. I can go on all day, and that's because SQL databases are awesome at scaling. So if you're thinking of building a startup where you really want to achieve high scalability, then choosing between SQL and NoSQL, it only depends on the kind of data you have. It's not about scalability, it's about the data. So remember what we say, good PHP code scales better than bad Erlang code, and good Ruby code scales better than bad Scala code. And that's the same with databases. Good MySQL knowledge, it's better than any NoSQL poor knowledge. Good experience with Postgres SQL, it's better than no experience with NoSQL. And again, I learned this the hard way. So we're moving on to the last imaginary issue for today. We need everything custom, so it fits our use case. I do not agree with that. But again, I want to share how Ruby on Rails can actually serve a lot of traffic with highly customizable storefronts. And again, I cannot share this enough because this is really how things goes. You choose a great framework that works well, and it basically does everything your customers want. There are great frameworks out there such as Spring Boot, Elixir Phoenix, or PHP Laravel, Ruby on Rails. They are all awesome frameworks made by very smart people, and they are all highly customizable. So there's no need, to build something custom as long as you know your own framework. I would suggest you using a framework for, critical parts of your application, such as authentication or whatever, transactions, whatever you think that can be point of failure if custom built. So, imaginary issue number 4 debunked. Frameworks already provide everything we need to implement most of the custom business logic we need in our apps. Hard to swallow pill, but that's how it is. How do I determine if my application is really scalable or not? Well, that's the biggest question we could possibly ask, I guess. And how do we do that? I would say we could ask certain questions to ourselves. Is my team scalable? I mean, what if we start writing something in PHP Laravel and then we see that we cannot go on with that because we need something custom? Is my team capable of taking this change? Is my team capable of concentrating on customizing the framework eventually? Or is my team capable of switching from MySQL to Postgres if needed, or Aurora, or whatever DB? So how can my team learn? That's more about learning than scaling the team. Are we adopting this technology because we're excited about it? Or are we doing that because it's the best solution to our problems? So that's a hard point for me because, I'm really hype-oriented person. I mean, I see a new framework, I want to try it and test it in production because I'm excited. I'm a developer. I want to do that. And I do really enjoy my work. But eventually, we have to serve a purpose. So if we see a new framework, if we see a new database, we have to think ourselves, do I really need it? Do I really need that level of scalability? Or am I doing that just because, I feel excited about it? Sometimes feeling excited, can last for a couple of days, but then you have to face the truth. Maybe it's too hard to maintain that database. Maybe it's too hard to customize that framework. And maybe we made a decision just because we were excited at first. And then, of course, do we know our app traffic? Do we know how our competitors are going? Or are we just making assumptions and speculations about how everything is going? But I want to have fun. I mean, I am a developer. I want to enjoy my journey as a developer, and that's absolutely fine. Just don't think of the next NoSQL database as a solution for all the scaling problems you have, and don't think of the next big JavaScript framework as something that will solve every single scalability issue we have. If you want to have fun, try to do that, in a smart way. So that was really all for me for today. I've been incredibly happy to have been here. These are my contacts. So if you want to reach out to me directly, I would suggest you follow me on Twitter, because that's where I'm most active. But of course, I'll be available for a chat with everyone. So I'll be there for the next minutes if you have any kind of questions. And again, has been a real pleasure to chat with you all. And thank you again for inviting me.
So the question is, how do you make the relational database management system secure within these applications?
Oh, okay. I mean, that's a good question, but I will answer with another question. I'm sorry. How do you make a NoSQL database secure? I mean, I know your point might probably be NoSQL database are not subject to SQL injections. That's absolutely true, but you still need to understand how to manage NoSQL databases. I mean, they don't provide any kind of security for free. The same way PostgreSQL or MySQL could provide any feature out of the box. You have to implement it most of the time. But again, it's up to us. We have to do a great job. So my point is, if you're choosing NoSQL because you're afraid of SQL injections, just try to understand how to prevent that on SQL databases, if that is the way you're more proficient in. If you're proficient with SQL databases, there's no need to run away from them just because you fear SQL injections. And all the other problems I can think of, they all affect both SQL and NoSQL databases. So I would say, don't worry, internet is your friend and will provide you all the answers you need to make your apps secure.
Yeah, thank you so much. So we have another question that is, what is the roadmap towards cloud computing for a total beginner person? What would you suggest?
Okay. So my suggestion would be, I would start by trying to understand how many cloud providers are there, because every single cloud provider, and there are many cloud providers out there, any provider can give you different choices and different options. For sure, I would say Google Cloud, it's one of the best, given that they can also give you a great dashboard where you don't have to be an expert to interact with your services. So that's the main advantage I see in using Google Cloud when compared to AWS or other competitors, Microsoft Azure and so on. So that's my first point. Try to find a provider that can really be easy to use, and Google Cloud for sure, it's one of the easiest one out there. And then just try to understand what you want to do in the cloud computing space. I mean, you want to create a REST API, you want to create an authentication service, then try to understand what do you need to do that. Authentication service, you probably need an HTTP server, a language runtime, networking capabilities inside your network, a database, and you have to make everything secure. So that's a good starting point because you're touching many different topics, So that's probably a suggestion I could give you. Try to understand what you want to do and how to do that. And as long as you start creating something, you will see that you have many different alternatives for building your services, and then you can start exploring what Google Cloud is giving you.
So we have one more question, and that is from Shiraz. He's saying, what do you think about distributed computing, and how do you see, what is the scope of it? What is the scope of distributed computing?
Okay, so distributed computing, it also depends on what we mean by distributed, because there are many different kind of distributed computing. For example, when we think of distributed computing, we think of, let's say, Elasticsearch or RabbitMQ or, that kind of softwares where the distribution part is due to the high traffic that they are subject to. So, for example, we have one single server and like Elasticsearch. So we have one Elasticsearch server and we get a lot of requests, and that server is not capable anymore of serving every single request. So what do? We decouple the service. So we start by putting one service like in Europe, one in Asia, and maybe one in the US. So depending on where you are, you will hit the server nearer to you, which is the nearest, and then those servers will sync up together so that every single server will have the same data. So that's one point. That's one reason why you want distributed computing. Another point, which is, I would say, more controversial, is to be closer to your users. And I want to give you an example of that. There is Cloudflare out there, which is doing an amazing job in distributing their computational model so that they have a global CDN and they're serving their Cloudflare workers, which are like the Google Cloud Functions, so serverless functions. They're distributing them worldwide so that if you're building an application in Pakistan, eventually you will be able to serve that exact application near to everyone around the world. But my question is, do you really need to do that? If you're building an application that needs to run in Pakistan only, you only care about people living in your country, which is fine. So you don't need to struggle, to give the exact same latency to people living in the US, which will never need your application. And that's just an example, but that's something to keep in consideration. Don't overthink your architectures unless you really need it.
Okay, so one more last question. So you have been using Google Cloud for a long time. So how do you see Google Cloud compared to Azure and AWS?
Yeah, so as I said before, I would say there are many different advantages of Google Cloud when compared to other cloud providers, and one for all, it's simplicity. Google Cloud, it's really easy to get started with when compared to other solution providers, and it's really easy to onboard people, and there are certain things that are not technical but are like how you feel when you work with Google Cloud, and that's why I eventually opted being a Google Cloud developer expert, because I feel like that could really empower developers to join the cloud computing space in an easy way. So that's my selling point for Google Cloud. It's easy. They provide you like a $300 of free credit, if I remember correctly. So you can start, you can see if everything is working fine with that generous offer from Google, and then eventually you will be able, to understand if you really need it. A cloud provider as such, or maybe you can just go with something else which is cheaper or free, and that's also fine. But eventually Google will try to will make you in a position where you can decide, and other cloud providers does not do that.